Now, we were just talking about how we can use the product rule or the quotient rule. And see, that's exceptionally important to us. Because what if I ask you to simplify this? The square root of 16. What do you guys say?
4.
You say 4, right? You don't say 16, you don't say 16 squared, do you? No. So the answer here is 4. And we know this. And we've known that for a long time, right? See, the challenge that we have is when we have something like this. Let's see the square root of 18. So when I have the square root of 18, what does that mean for me?
It's going to be a decimal.
It's going to be a decimal, but here's the thing. We're not going to leave it as a decimal, though. Because we can do better than that.
Turn to a mixed number.
A mixed number?
Fraction.
If you have a radical that's not a perfect square or cube or whatever it is, whatever the index is you're dealing with, if it's not perfect like this guy here is just 4, then the result is going to be some decimal that's going to be irrational, which means it can never be written as a fraction. It can never be converted to a mixed number. But what if I did this? Do y'all agree that I could write this as 9 times 2? Now, why did I do that?
9 times 2 is 18.
Well, I could have used 6 and 3, right? What's special about 9 and 2, considering that we were just talking about the product rule for radicals?
Well, those are squares.
Well, that's a square, right?
Yeah, at least that one is.
So according to the product rule, I should be able to write this as the square root of 9 times the square root of 2. So even though 18 was not a perfect square, it had a factor that was a perfect square, right? 9's a perfect square, 9 goes into 18. So what's the square root of 9?
3.
So we're going to write this as 3 times the square root of 2. Just like that.
I remember doing
So this right here is a simplified and exact answer. If you try to convert this to a decimal, it's not going to be correct. So this is exact, and it's simplified. Okay. And the way that we would read this, because I want to make sure you do say things correctly, so you're not saying the thingy with the thingy in the house and the thingy and the thingy and bottom of the thingy. So you guys are kind of get crazy on me there. We'd read this as 3 square roots of 2. Please don't say 3 root 2. That just sounds really weird. Don't say 3 radical 2.
If you want to be grammatically correct while we're at it, any number under 100 needs to be written out.
If it were a formal paper and a document.
3 square roots.
Yes. So, do I need to write this out? No. We're using math here, so I'm not going to write that out using words. So, you read this as 3 square roots of 2. Okay. I think we should try another one, right?
I sure do.
Because I want to make sure that you guys are totally with me on this, right? What about the square root of 75? Is this guy a perfect square? No, but could you maybe rework this guy so that you can see there's a factor that's a perfect square?
15 times 5.
You could do 15 times 5, but neither one of those is a perfect square.
25 times 3.
But you could use a factor.
Bingo.
I don't even know. But you see this is 25 times 3, right? And the reason you guys said that is because, well, 25 is a perfect square. So, That's a perfect square. What's the square root of 25?
5.
So do you guys agree the square root of 25 is just 5? But who is not perfect?
3.
So the 3 has to stay inside the square root.
I see what you're saying. So you can't say 15 times 5 because 15 is not a perfect square.
Right, we're looking for factors that are perfect squares, but if that's the first thing that you think of, I don't want to I don't want to discourage you from using that. Because let me do square root of 75 again. Okay, I just want to make sure that you guys are aware of what you can and can't do here. I am a big believer in using factor trees. So if you say this is 15 times 5, that is correct and it's valid. However, are either one of these guys a perfect square? No. Have you factored everything completely though? So when you finish factoring, because 15 can break down, that breaks down to 3 times 5. Do you all agree? Now I'm going to just kind of lightly cross those guys off, and the reason I'm doing this is because you broke them down. So here at the end you see your 3 factors, the 3 factors of that prime factorization. If I'm talking about a square root, I need to find a factor that's a perfect square, like the 25, or I need to find how many of the same factor. I need to find 2 of the same factor if it's a square root. Square root means you're looking for things that are perfect square. You have 2 of the factors. So I can look at these 2 guys right here. I have 2 factors of 5 on the inside, and when I take the square root, what am I going to get on the outside? No, I'm not going to get 25 on the outside, but I'm going to get a 5 on the outside. And I'm still going to be left with a 3 on the inside. And it does give you the same thing. Like when I had the square root of 18, let me revisit that guy. Again, it all depends on how your mind works. If you said this guy is, say, 3 times 6, and this guy breaks down as 2 times 3, I'm looking for a perfect square. In other words, 2 of the same factor. Do I have that? I have 2 factors of 3. So that's going to give me 2 3s on the inside is enough to give me 1 3 on the outside. So that 3 comes on the outside. Did you have any factors that were not perfect squares?
2.
And that's what stayed on the inside. You have to be able to see these numbers as squares or as factors. You have to see them in terms of multiplication. If you think of this in terms of addition and subtraction, then you're never going to be right, ever.